Okay students, now let's go ahead and learn about the chemical characteristics of acids and bases. With this we will also learn the concept of pH. Alright, now let's go ahead and understand the chemical characteristics of acids and bases. Acids are sour, bases are bitter in taste. Litmus, acid shows or converts blue litmus red. Methyl orange, color of orange to pink. Phenolphthalein, it is colorless. So when I add phenolphthalein to acid, it is colorless. When I add methyl orange, it turns pink, and when I add litmus paper, it turns red. Now, mineral acids like HCl, H2SO4, they cause burns to the skin. In a similar way, litmus of base turns red to blue. Methyl orange turns orange to yellow, and phenolphthalein shows pink color, right? And lastly and very important, it is soapy. That means if you see the soap, regular routine soap, it is sticky because of presence of alkali or bases like NaOH that are present in the soap. That makes it soapy or sticky in nature, while acid causes burns. Alright, now after this, let us understand the concept of pH and let us apply the concept of indicator to the pH. Alright. So what I am doing, I am just eliminating this part and I am keeping only this part so that we can clearly understand the concept of pH and apply it with respect to acids and bases. Right. Now what is pH? Let's first understand. It is written like this, small p and H in the superscript. So pH is called as potential of H plus ion. It is called as potential of H plus ions. Alright. And the formula for pH is equal to negative logarithm of concentration of H plus ion. Now why this formula is being used? What are the logic behind it? Right now it is not part of our syllabus. But you must understand it is negative logarithm of concentration of H plus ions. Now what is the range of pH? What is the range of pH? Range of pH is 0 to 14. It can be negative also, right? It can be negative. In certain cases it is negative also, but right now with your standard it is between 0 to 14. So the pH is between 0 to 14. Alright. Now, how we bifurcate the acids and bases with respect to pH? So, when I keep over here at the center, that is neutral part, here the pH for neutral solution, neither acid nor base, pH is equal to 7. pH is equal to 7. And if I move from left to right, that is over here, acid is having the pH between 0 to 7 and bases are having the pH between 7 to 14. 7 to 14. And if you see carefully, as the pH decreases, it is indicating strong acid. Strong acid have low pH value. Low pH value. And as I move towards the neutral part, that means it is weak acid. Weak acid. Weak acid have high pH. But again, it is less than 7. High pH, but it is less than 7. And now in the same way, center is the neutral. On this part, it is 7. That means closer to the neutral. That means these bases are weak base. These bases are weak base. Weak base. And as I move towards the 14, these are strong base. These are strong base. Away from the neutral, strong base. Away from the neutral, strong acid. Center, pH 7 is a neutral part. I hope this much is clear to you. Alright. Now, in this particular thing, they can twist and ask you the questions like this. they are giving you, say for example, pH range. They are giving you a pH range, say for example 2, say for example 5, say for example 7 point, or I'll take 8. They are giving 14. And they ask you that which one is the strong acid and which one is the weak acid. So lower pH means strong acid, higher pH means weak acid, very weak base because it is close towards the neutral, so it is a weak base, and this is a strong base. So very simple. The intermediate part will be weaker, that means this side weak acid, this side weak base, and the extreme parts are the stronger parts, that is strong acid and a strong base. Alright, now they can ask you like this also, that which one will contain more number of molecules and which one will contain more number of ions. That we know very well, that if it is a strong acid, more ions; if it is weak acid, less ions; if it is a strong base, more ions; if it is a weak base, less ions. So strong acid, more ions; weak acid, more molecules; weak base, more molecules; and strong base means more number of ions. Alright, now let me show you practically that how the pH indicator works and how the litmus paper works. Alright, now dear students, let's check. I am having 3 solutions with me, whether they are acid, base or neutral. See, these are having, I am having litmus paper. One is blue and one is red. Let us check that which one is an acid and which one is a base. So first I am taking red litmus, and if I find if it is changing, remember one thing, for litmus paper it should be moist, it should not be, that means you have to check that of aqueous solution. Now if you see carefully here, there is no change in the color of the litmus, it is showing me just the red litmus. Alright, so no change in the litmus. Now let me check the same solution with respect to the blue blue litmus. If I check like this, and if the color of the litmus changes to red, it will be, yes, it is acidic. Alright, this is acidic. Now if I use with respect to this solution, oh, no change, that means this solution is not acidic. Now let's go ahead and check with this. Yes, see, alright, with just a simple, it has turned blue. Alright, so this solution is basic. Fine. Now let us check with the universal indicator. If you see carefully, the universal indicator has complete pH range, that means from 0 to 14. Now I'll show you that how it looks when I add water to the universal pH indicator. Alright, so I'm just taking this much, and now see, if I add water, yeah, the color is green. Alright, fine. Now if I take little bit of this solution which is acidic, and if I add this neutral litmus solution to this, yes, dark red means it is a strong acid. Similarly, if I use I add this basic solution to this, basic solution to universal indicator, oh, it has turned violet, that means it is a strong base. I hope that this much part and concept is clear to you. Alright, thank you.